asking you, for each rational function, find all numbers that are not in the domain. What's the one number that's not in the domain?
Not 0.
Yeah, why is this one not in the domain?
Because you can't have the denominator equal 0.
Exactly, right. So what is the domain of this?
Not 0. Every real number is 0.
Excellent, well said. So you could say to x such that x does not equal 0. Or all real numbers except for 0.
Oh.
Nice.
So that's the answer.
Yes, and then it says give it in set builder notation. That would be a great answer right there. Yes. Okay, so it says write each rational expression in lowest terms. So it's actually asking you to simplify, right? What can you factor out of the top?
6.
Sets, you left the room, so we're doing a different one. We'll come back to 23 now that you're here, okay? But it's m plus what is left?
3.
3. And then what can you factor out of the bottom?
7.
It's going to be m plus.
3.
So what's in the top and the bottom, and it's all being multiplied.
So you can cancel them out,
And then you're left with
6
what?
over 7.
You're done.
Oh,
That's it. So what this tells you is no matter what value you plug in for m, what are you always going to... Is that true? Wait a minute. Hold on a sec. That?
yeah.
So what do you have to do first?
Do you have to factor?
Yeah, you have to factor the denominator. So you have 3x plus 1 over, and you know it's going to be 2x and what? X. And now you just have to test things. You know that it's...
Zero, right?
What?
0, right?
No, there's no equals 0 here. We're just factoring. We're just factoring. We're not solving. We're just factoring right now. We're just factoring. That's all we're doing. All we're doing is rewriting. We're not solving anything yet. We're not solving anything yet. We're just factoring. Do it one step at a time. So the bottom there, that -6, what does that tell us about one of the two terms, remaining terms has to be what?
Negative.
Negative. So we just test something here. What numbers do you want to test?
3 and -2.
How about, you know, plus, you want to do plus 3 and minus what?
2.
Plus 3 and minus 2. And what do you do once you have this? What should you always do? We need to make sure we check. We need to make sure we check. So that's going to be 2x squared minus 4x plus 3x minus 6. Is this close to what we want? It's close, but what's wrong?
Change the
What's wrong? I'm not asking you what to do. I'm asking you what's wrong.
negative x.
The x is negative and it should be positive. Correct. So that's the only thing that's wrong. So what's the only thing we need to change?
That's not.
Yeah, so don't erase this. I would just do this and say, okay, this didn't work. So instead we'll do minus 3 and what? Plus 2. And let's see if that works. What are you going to get now? 2x squared plus 4x minus 3x minus 6. Do we end up with what we want? We do. That is what we want. Now we're not done. It's asking what numbers can't be in the domain. So what's the illegal operation we don't like happening? We don't like doing what? What operation?
Division?
By
Negative.
what is the illegal dividing by 0 is the division we don't like to do. Dividing by 0 is the division we don't like to do. So what do we now set equal to 0? The bottom. Now we do this. 2x minus 3 times x plus 2 equals 0. We want to know when it's equal to 0 because those are the things that you can't plug in. That's what it's asking for. So what's the OR statement we get to do right now? What's the OR statement we get to write down? Gabby?
2x minus 3 equals 0, or
Yep.
x plus 2 equals 0.
Nice. So we know 2x is equal to 3 or x is equal to -2. So x is equal to? So these are the two values that you can't plug in. You can't plug these in. So what's the domain then? Can someone tell me what the domain is? Yes.
All real numbers except for those two.
Yep. 3 over 2 or -2. Yep. I like this notation. That's my favorite right there. Can someone read that out loud to me? What does that say? What's that bar mean?
X such as x does not equal 3 over 2.
X such that x doesn't equal 3 over 2 or -2. Correct. You could write out the sentence. That's fine. All real numbers except whatever you're comfortable with, I'm fine with. The biggest thing you need to get your head around is what is the domain, which is great. Okay.
X plus 4.
X plus 4. And what's still in the bottom?
X plus 4.
So what cancels?
X plus 4.
Chris is just going to say x plus 4 a whole lot. So what is this simplified to? X. Yay. 23. Which rational expression is not equivalent? So you have to check each of them. I'm not going to do it each way. You have to check each of them to see if they are equal. You have to check them. That's a great question to do. It just takes a little while. We're not going to do that. So I'll do one of them. I'm not going to do all of them. So this is number 23. So it says x minus 3 over what? 4 minus x. So we need to compare that to, what's the first one we need to compare it to?
X minus 3 over.
Nope.
3 minus x.
3 minus x over
X minus 4.
x minus 4. So what's the only thing that changed between those two? Are they the same? The order. So x minus 3 turned into 3 minus x, and 4 minus x turned into x minus 4. What happens when you reverse subtraction? It changes the sign, right? But what happens if you change the sign of the top and the bottom? It stays the same. Yes. What's 3 minus 5? What's 5 minus 3? 2. So what happens when you switch the order of subtraction? It changes the sign. But if you change the sign on the top and the bottom, what happens overall?
because they both change.
negative.
They both. So it goes from positive to negative or negative to positive, but both of them do the same thing. They both flip. If they both flip, nothing happened. Okay, so that one's the same. So then you need to compare it to, what's the next one?
So that,
X plus 3 over 4 plus x. What changed there? The sign. Are those going to be the same thing?
No.
No, that is definitely not the same. No. Another way you can do this too is pick a number for x. That is not always going to work. It can't prove that they're the same, but it can prove that they're different. It can't always prove that they're the same, but it can prove that they are definitely what? Different, right? So because if it works for one number, it might not work for another number, but if it doesn't work for one, it means it's not the same for all numbers. So for this one, pick a number, 2 or 3. What's 3 minus 3? What's 4 minus 3? 1. What's 0 over 1? 0. Plug in 3 here, you get 6 over 7. Is that the same thing? So one way to check is to plug in a number. If it's a way to prove that they're different, but not to prove that they're the same. Okay, so the next one. Negative 3 minus x over 4 minus x. What's the only difference between this and this one? No, that's not the only difference.
Oh, three.
It flipped the top, right? But what did I say happens when you flip the order of subtraction? It changes the sign, but then what did they put out front? So is this the same? Yes, it is the same. When you flip the order of subtraction, it flips the sign, but they put a negative out there, so what happened? Nothing. So this is the same. And what's the last one here? Negative x minus 3 over x minus 4. Ah, they just flipped the bottom one. So is that the same? It is. All they did was flip the bottom one. But they put the yeah, exactly. But they put the negative outside, so that balances it out. So you have to check them one at a time.
Write each rational expression in lowest term.
Yeah, so simplify. So what's left?
T plus 6.
Nope.
That's what I said. T plus
Okay,
6.
t plus 3. And what do you see on the bottom, everybody? What do you see? Difference of squares. So what does that factor into?
So T plus 9 and T minus 9.
No, close. T plus
3.
and t. So what cancels?
That would be 2 over
T minus 3. That would be the lowest. That would be the most simplified form right there. Instead, how do you do the first one? A. What do you have to do first? What do,
Make sure there's a common denominator.
does it have a common denominator?
Yes.
It does. So what can you do with the numerators?
Add them.
Just add them. So what do you end up with? 3y plus x over 5. But you could do this because what do you have?
A common denominator.
This rule does not change with rational functions. To add or subtract rational functions, what do you have to have?
common denominator.
A common denominator. Now, do we almost have a common denominator here?
Yes.
We do.
Almost.
Almost. We almost. But does that mean that we have it? No. So what do we have to make? So let's just space this out a little bit. Let's say I space it out right here. Minus, well actually I'll just space it out here. Minus 1 over q plus 1. How do we make a common denominator without changing the overall value? What's the only thing we're allowed to multiply by and it doesn't change the value of something? 1. Or a form of 1, right? There's a lot of different ways to make 1, right? Bookshelf over bookshelf is 1 because you have the same thing on the top and the bottom isn't 0. So what do we multiply the first one by? What?
Negative.
Nope.
No, the first one's
Oh, the
always
first.
positive thing.
Nope. Nope. You have to multiply both of these by something.
No, 1 over 1.
Nope. Okay, I'll ask it differently. 1 over A plus 1 over B. How do we go about adding those together?
Add A on both sides.
There's no sides.
Multiply by B for the first one.
You can only multiply by forms of
Multiply by
1.
AB.
Nope.
B over B.
B over B. On which one? On which one, Fitch? Which one do we multiply by B over B? Thank you, Sarah. B over B. What's another way to say, Sarah? What's another way to write B over B? B over B simplifies to what? 1. So is that legal? Can we do that mathematically, like legal? So what do we multiply 1 over B by? A over A. What do we get on both of these? What does this simplify to?
That's not the same on both sides.
There's no sides here. There are no sides. This is an expression. There are no sides to this. No equal sign. So what does this one simplify to?
B over AB.
And why did you write it as AB?
Because of multiply.
They're multiplied, but why did you write BA?
Because alphabetical is
Because alphabetical order. Exactly. What about this one right here?
A over B, AB.
AB. Hey, what do we have now? We now have a common denominator. So what can we add together now? Sarah, can you stay with us while we do the important stuff, please? The numerators. So we have A plus B over what? AB. So let's simplify this though. What does the top simplify to? That's Q plus 1. What do we distribute on the top? The negative sign. So it's going to be minus what? Plus 1. And the denominator stays the same. Don't multiply it out.
Is it gonna be 2?
What cancels on top? What cancels on top? The Q's cancel on top. So what are you left with?
1 minus.
No, 1 plus 1. What's 1 plus 1? So it's 2 over Q minus 1 times Q plus 1.
Why didn't we just cancel the Q plus
You can't because it's a minus sign. It has to be multiplication. That's really, really careful. Remember this? Remember we did this yesterday? Like, what is x plus 6 over x? Can you just cancel the x's?
No.
So if there's a plus, you can't. It has to be all multiplication. This right here would be an excellent final answer right there. It shows me that you got the right denominator and you stopped at the appropriate place. Does that make sense?
m minus 6 and m plus 1?
M minus 6 and what?
M plus 1.
Nice. So, do we have...
Couldn't also be m minus 3.
Wait, no.
It's close. No, isn't that right?
No,
Same
because
thing.
it has to be a negative.
It's a positive 6.
Yeah.
So what, yeah, that's close, but it doesn't test right. So what is it?
Oh, it's a positive.
M minus 3 and... Yeah, you got to be careful with the signs. Okay, so here's the question. First question. Do we have a common denominator? No, we don't. So what do we have to make? Correct. Are we kind of close to a common denominator?
Yeah.
We are. What's common to both denominators?
M minus 3.
So at first you might have thought like, ooh, I need to multiply this by this over this. But you don't need to do that. What's missing here?
The m minus 2.
M minus 2 is missing. We can't just multiply by m minus 2. We need to multiply by,
M plus, or m minus 3 or minus 2.
nope, m minus 2 over.
M minus 2.
Remember, we can only multiply by
1.
forms of 1. This right here, what is that we just multiplied by? A form of 1. A form of 1. What do we multiply by over here? Are we allowed to do that? Yeah, because this is just a form of what? Just a form of 1. So it doesn't change anything. Now, remember, don't multiply things out. Like, don't distribute unless you have to. So if we write all this out, what do we get on top here? We end up with m plus 4 times minus 2 minus 2m minus 3 times what?
M plus 1.
M plus 1. And what's the new big denominator?
M plus
1
times m
minus 3 times...
m minus 2.
Yeah. You have now done what I asked you to do, which is combine the fractions. You're going to stop at this point because all I'm asking you to do right now in this problem is to combine the fractions. It may seem a little disconcerting to you because you want to do more, but here's the thing. I need you to realize that at this point, you've done the really important thing, which is form a common denominator and put them together. Now, could you play around with this to see if things simplify up here? Yeah, you have to multiply it out. Maybe some stuff cancels because there's like a minus, right? Do you understand what I'm saying there? So maybe there's more to do, but I want you to recognize you've done the really important thing that's new today, which is add and subtract rational functions. Add and subtract. This one factor nicely? Yeah, it's kind of nice.
Yeah, it does.
X plus
5.
5 squared, right? Plus 2 over what? Oh, nice. Okay, so what's missing on the one on the right?
X plus 5. Another X plus 5.
Another x plus 5, exactly. So you have x plus 5 over, and what do you have over here that's missing?
X plus 2.
Over x plus 2. Exactly. So, right here, do we now have a common denominator?
Yes.
Why were we allowed to multiply by the green things?
It was a
Form of 1, right. So what do you end up with? 5 times x plus 2 plus 2 times what?
5.
X plus 5. And what's the big denominator now?
X plus 5 squared.
And x plus 2. Yep. You could say x plus 5 twice. That's fine. Now, this one's relatively straightforward. Could we simplify this pretty easily? What do we do on top? One word.
Distribute.
So 5x plus
2x plus 10.
and what happens to the denominator? Don't multiply the denominator out unless you have to. We don't have to and you don't want to because it's a cubic. Are there like terms in on the numerator right now? Are there like terms?
Yes.
There are. 7x plus what?
20.
Sarah? And what's here? I'm going to put the x plus 2 first. That right there would be a great final answer. There's nothing else you can do on that is what I'm saying. And it shows me you got the right denominator. So I'm going to have you practice another one. This one. What's different now?
Yeah.
Yeah, so I'll space it out a little bit. You have 3 over x minus 2 plus 5 over x minus 6 over, what do you factor out here? Oh, I'm sorry. I got to actually unfreeze it. Sorry. 6 over what? What do I factor out?
X
Times.
Nope.
X minus 2.
Can you see it? Nice. So are they all pretty close?
Yeah.
What do I have to multiply the first one by?
X.
X over x. What do I multiply the second one by?
X minus 2 over X.
Do I have to multiply the third one by anything? No. So what do I end up with? 3x plus 5 times x minus 2 minus what? Over.
Over X times X minus 2 squared.
No, it's not squared.
Oh,
It's just the same denominator. We don't square it. We're not multiplying.
I thought you had the
Nope.
other one.
Nope.
Like the side
Can you
one.
clean up the top one, the numerator, a little bit?
Yeah.
So what do you have? 3x plus
5x minus 10 minus 6.
all over x times x minus 2. Do we have like terms on there?
Yeah.
Sorry, this got a little weird. We do? So how many x's on top do we have?
8x.
8x, 16 I think, over x times x minus 2. Can we factor out anything on top? What is it? 8 times? What's left on the bottom? Oh, what can we do? Turns into? Boom!